x. But if you solve it using your asymptote, you need to make sure that you have your x value, which is -2. So you'll have 1 minus 2, and then the other one, this one is associated with the movement of y, so this will become 1 plus 1. Therefore our new asymptote will be -1 and 2. Remember, in terms of your hyperbola, when you want your domain or range, you will always say, if it's your domain, x is the element of any real numbers, and then you say x is not equal to the asymptote. What's your asymptote? -1. If they wanted the new range, we were going to say y is the element of any real numbers, but y can never be equal to what? 2, because those are your asymptotes. Now 3.14, it says determine the equation of the axis of symmetry of f with a negative gradient. So it means if m is less than 0, then your m is equal to -1. Now if you use your equation, remember you can determine that equation using this format. So what you're going to do is you are just going to insert -1 in front of this equation. So what you do is you are going to say y is equal to -1, and then open bracket x minus 1. But that -1 must only affect x minus 1, not the +1. And then finally your equation is -x plus 1 plus 1, which gives you -x plus 2. Or alternatively, you can use y is equal to -x plus c, where you have already substituted the -1, and then you use your asymptote, which is 1 and 1, to find the value of c. Y, it's 1 minus, what is the x value? 1. The x value, it's 1 minus 1 into 1 plus c. Therefore c will also give you 2. Therefore your equation will be y is equals to -x plus 2. Now 3.2, we are given k of x 1/2 to the power of x minus 4. Now 3.21 says, is k increasing or decreasing? Now remember, your form of an exponential function, it's y, it's equal to a b x plus p plus q. If b is between 0 and 1, then your function will be a decreasing function. And if b is greater than 1, then your function will be an increasing function. Now, in this case, the value of a is 1, and then your b value is 1/2. So it means b lies between 0 and 1. Therefore, we can say for 3.21, we are having a decreasing. We can say k is decreasing. Now 3.22, now if k is translated 4 units up to form t of x, determine the equation of the inverse of t. This should say this should be t of x, not k of x in the form y. Therefore, what we need to do is we are having k of x is equal to 1 over 2 to the power x minus 4. Remember, if they're saying k is translated 4 units up, the upward movement it's associated with y. Therefore, we need to add plus 4. Therefore, the new equation, which will become t of x, is going to be 1 over 2 to the power of x. Remember, we need to find the inverse of this equation. And then we know this is the same as y. It's equal to 1 over 2 to the power of x. Now, in order to find the inverse, we need to start by interchanging the x and y values. Therefore, we're going to have x is equal to 1 over 2 to the power of y. And because it's an exponential form, we need to introduce the log. And when we introduce the log, the base of the exponential form will become the base of the log. So the base of the log will be 1 over 2, and then where you are having y, 1 over 2 to the power y, you'll have what? X. And then where you are having x isolated, you'll have y isolated. So that's your equation for the inverse.